In the previous lecture, where we have calculated the volume of the batch reactor by using the fundamental concept of the space-time, right? So the way of calculating the volume of the batch reactor by using the fundamental concept of space-time is conceptually correct, but partially incorrect, right? So we need to opt a different way, the actual way of calculating the volume of the batch reactors, right? So in today's lecture, we'll understand how we actually calculate the volume of the batch reactors, right? So let's get started. Okay, so in the previous lecture, lecture number 13, where we have calculated the volume of the batch reactor, right, for the zeroth order reaction, okay, by using the fundamental concept of the space-time. Okay, so in today's lecture, which was conceptually correct but partially incorrect, right? So in today's lecture, we are I'm again going to explain you the actual way of calculating the volume of the batch reactors for the zeroth order reaction, for the first order reaction kinetics, right? So let's get started. Now let's say, so how to start? Okay, we need to understand that from where we need to begin. Okay, so let's say we are trying to understand and design the volume of the batch reactors, right? Which means, let's say, for the certain volume of the batch reactors, we have the constant initial concentrations of the reactants will be present in the reaction environment, right? So in that initial concentration, what will be my number of moles present in the given volume of the batch reactor, right? So likewise, we need to think for the designing of the batch reactor's volume. Okay, so let's say, for example, let's say we have any certain volume of the batch reactors. Okay, so in the batch reactor, we have the presence of reactants, right? Reactants are present in the reaction environment of the batch reactors, right? So the initial, or which means some concentration is present in the reaction environment of the batch reactor, right? Now what does the concentration term means? Concentration, which means the moles of reactants present per unit volume, it's termed as the concentration, right? So first of all, we are going to calculate the volume of the batch reactor by using the zeroth order reaction kinetics, where the given rate law is minus RA is equal to K, right? K is equal to 0.04 moles per hour cubic decimeter. Okay, so let's say we have certain volume of the batch reactor in which we have initial concentration of reactants present in the volume of the batch reactor, but yet we don't know how large volume